Lesson number 27. Lesson number 27 is about freely falling objects. The first thing that we need to remember is whenever object moves downward, for example, this is an object. As it is going down, what will happen? The first thing is speed increases at a constant rate. What is the first thing? Speed increases at constant rate.
Constant rate here means
Constant rate mean acceleration. Constant rate mean acceleration. So it will continue increasing at a constant rate. So it means that if in first second it covers 5 meter distance, in second it will not cover 5, it will cover more than that. And our mathematical calculation told us that when something is falling, so distance is directly proportional to time square. When object goes down, for example, in first second it is 5 meter, second it will be 2 square. Second mean 2 square times 5, 20. In third second, 3 square, 9 times 5. So if in first second, if I make a table here, this is the time and this is the distance. Mathematically, we proved it. In first second, it covers 5 meter distance. This is meter and this is second.
One is falling.
Yes, one is falling. In second, its distance is 20. So how it comes 20? 20 is you will take square of this time with the initial distance 5. Similarly, 2 square is 4 times 5 is 20. When it will cover for third second, it will become 3 square 9 times 5, 45. So can you tell me how much it will cover in fourth second?
So it will be 4 equals 4 squared times 5. So it will be
80.
16 times 5.
80. So this is a process that usually goes as it is. Okay. So now we found first thing that it falls with a constant rate. So Galileo was a scientist. He talked about the same thing. What Galileo told us? Galileo told us that all the objects, either they are heavy or lighter, they will fall with the same rate. It will never happen that a heavy object fall faster and a lighter object falls slower. Why? Because he said that we need to take care of air resistance. If there is no air, like we have air here, but if we move to vacuum or space, what happens? This bottle and me both fly at the same rate. Why? Because there is no air resistance. So same thing happens if we evacuate the air or the air resistance is removed, a hard wall and a paper will fall with the same speed. A rock or a stone and a feather will fall with the same rate. So yeah, so this is practically if there is no air. I said, oh, but here is air. How you will evacuate it?
No air only.
Without the air resistance. So what he told us, without air resistance, without air resistance, heavy and light object, heavy and lighter objects fall at same rate or acceleration, and he named it acceleration due to gravity. He named it acceleration due to gravity. So now whenever something is moving or falling, so what we will say, a freely falling object has a constant acceleration and its value is
G.
its value is 9.8. and denoted by G. Its value is meter per square second because this is the acceleration.
That's the gravity?
Yes, acceleration due to gravity we call it. Its value is 9.8 meter per square. So I can say it is denoted by G, which is 9.8 meter per square second. Okay, this is the second thing. Third thing is, as you said that when something is falling, so as it keep on falling, its speed increases until a certain level. That is called maximum speed. After that, it will not further increase and it will become constant. I'm repeating my statement. When something is falling toward the earth, speed increases. It keep on increases with constant rate, that is 9.8 meter per second in 1 second. It will continuously increase until a certain level. At that level, it will increase at maximum and then stop further increase in the speed.
So there is a limit.
That limit is called terminal velocity or terminal speed. So what I said here, I will just write it. What is terminal speed? Terminal
when it stops.
Velocity stops increase. It doesn't mean that it will stop.
Yeah. So
its further increase will stop. So terminal velocity is maximum velocity attained by falling object. Falling object. And after this limit comes, it will stop further increase. So this is the terminal velocity. Now coming to one last thing. It means that when the object are falling, they are also following straight line path. And for straight line path, we use equation of motion to solve the problem. So to solve the problems related to freely falling object, what we use? We use the same equation of motion. So to solve problems related to problems for freely
falling objects.
Falling objects, we use same equation of motion. Equations of motion, but a slighter change. What are the changes? For example, we have first equation. What is first equation? V is equal to plus 80, but A here will replace by GT. So this will be the first equation. What I did, I replace A by G. Okay. Second equation, x minus x naught will change into y minus y naught is equal to V naught. Y is vertical, x is horizontal. So it was equation of motion was car was moving right, left, forward, backward, but now up and down. So that's why we use y. V naught t plus half g t square. So same thing, only I change a with g, I change x minus x naught with y minus y naught. So I will change this to y minus y naught. Okay, third thing, third equation, 2g y minus y naught is equal to v squared minus v naught square. And there are few very important points that we need to take care about. First of all, if something is going up, what will happen? Upward motion. For upward motion, what we need to take care? For upward motion, if this ball is moving upward, okay, G will be negative 9.8 meter per square second. When going up, it will be negative 9.8. It means it is moving, its velocity is upward decreasing, so G is downward.
So when it stops, it will start positive.
Yes. So why it is negative? Because G is downward all the time. G remains always downward. If an object going up or downward, because gravity is pull of the earth, that's why it will remain downward. Okay, G is this one and it will always remain downward. When it reaches at the maximum height, its speed will be maximum height, V will become 0 meter per second. Okay, for downward motion, what will happen?
It will increase.
For downward motion,
The G will be.
yes, for example, it starts moving downward. First of all, its initial velocity, if you drop it, if it is said we throw, then it is different thing. If you dropped it, then V naught is 0. You just dropped it, V naught is 0 meter per second. And now its gravity is 9.8 positive meter per square second, but still it will be going downward. So gravity is always downwards, but its value is positive going downward and negative going upward. So we will substitute these values while we are going to solve. So this is the only change in the equation that we need. Now what to do? When we are going to solve the problems, we just go through very important thing. Let me solve one simple example and we will understand how to use these equations. For example, our first, where is the question? Question is here somewhere. Let me start with the first question of 2.7.
39.
Yes. Starting with question number 39. You will see this is the same as we did in the 2.6.
Yeah.
So the method will remain the same. The point of view is the same. The solution way is the same. Only new thing is acceleration is changed to gravity. That's the only thing that is changed here. Okay, this is the first problem. Before I start reading, what I need to do, if you remember,
we'll make a box.
we need to make a table or a box for different values. Okay, so the box here will have all those 5 values which we used to have. So first of all, we need V naught, V,
G,
G,
T,
T, and Y minus Y naught. So this is it. We will just substitute the values and we will get what will happen. So when we read this problem, what is the first thing in it? A stone is dropped. Dropped means it was at rest. So it is 0 meter per second is initial velocity. From a cliff, it is seen to hit the ground below in this time. So 3.55 second is the time. And you are asked to find how high the cliff is. So your question is to find y minus y naught. G is going down with be 9.8 meter per square second. So V is not here. So when V is not here, it is second equation of motion. 2G y minus y naught is equal to V squared minus V naught squared. So 2 into 9.8. Can you hold your calculator, please? Y minus y naught is to find V square is sorry. I just did a mistake. This equation is not applicable. This is third. I want to use the second one. Second one is y minus y naught is equal to V naught T plus half AT square. So I will use y minus y naught is equal to V naught T plus half A is converted to GT square. So y minus y naught is to find V naught is 0 multiplied by the time 3.55 plus half G is 9.8 into time is 3.55 squared. First of all, when 0 multiplied by something, it will become 0. So first part is y minus y naught is equal to 0 plus half time 9.8 times 3.55 square. How much? 61.75. So we can say the height of the cliff is approximately 62 meters. So in two significant figures, we wrote it in 62 meters. So this was very easy. Let me solve a question that is something is going up because it was going down. So let us do a question. If something going up, what will happen? A ball player catches a ball after throwing vertically upward. Yes, this question we can solve it. This is it. In this question, there are two more new things that we need to learn. First of all, they are having two questions here. What are those two questions? I will just give me a second, go through it. This question has actually 2-3 hidden things that we need to remember. What are those hidden things? First of all, it is saying a ball player catches a ball 3.4 seconds after throwing it vertically upward. He threw the ball up. First thing is, if you look at this, this is the starting position. He throw it up, speed decreases, it becomes 0 here, and then it go back to his hand. One thing, keep it in your mind, when something going up and going down altogether, G will be negative 9.8 meter per square second. Going up is negative, going down is positive, but if it is going up and down, then we take negative. We will not consider it positive, one thing. Secondly, if you throw ball up and you catch at the same position, the velocity of the ball when you throw and you catch will be same. If you throw a ball with 10 meter, it goes up and coming down. When you catch, it will be again 10 meter per second. So speed will be same. Now what he is saying, it is having two things here. The first thing is V naught we don't have because he is asking us for the V naught. So first thing is V naught is question mark. What is V? We don't have. What is time? We have 3.4 second. Then G is, I told you when going up and down, negative 9.8 meter per square second. And last thing, Y minus Y naught. This is very important point. When you throw a ball up,
So interesting.
just tell me one thing. You are at this position. You roamer around and you get back to this position. Your initial and final position is same. It means no displacement. So ball was going up and getting back to the hand from where it started. So initial and final position is same. Y minus Y naught is 0. So you are asked to find V naught and V is not related here. So which equation you will use? Again, second equation of motion, that is y minus y naught is equal to V naught t plus half gt square. Just substitute the values. Y minus y naught is 0. V naught is to find. Time is 3.4 plus half negative 9.8 into 3.4 square. So first of all, this is 0 is equal to 3.4 V naught. Can you give me the answer of negative 9.8 times half times 3.4?
3.4 squared, right?
Yes.
3.4 squared. The answer is negative 56.60.
You did all?
Yes.
Negative 656.64.
64. 0.5 times negative 9.8.
Yes.
Times 3.4
squared. So you did it. Okay, now this negative term will go on the other side, become positive. So it will become 3.4 V square is equal to, negative will change it to 56.64, divide by 3.4 on both sides. So your initial velocity V naught is equal to
negative 6.29.
Negative 6.29. So you can approximate it to, why negative? It's not negative, sorry. Already negative was changed. So 56.64 divided by 3.4, 6.29. So that is approximated to
56.64 divided by 3.4. 4 equals 16.66 actually.
What is the answer?
The answer is 16.65.
So this answer is wrong. What is the answer of this term? Can you give me please calculator?
6.5 times negative 9.8 times 3.4 squared. Could you please calculate?
Can you give me please? So this is 0.5 times negative 9.8 times 3.4 squared. This answer is 56.64. That was correct. So it was the first answer, 56.64 was correct. Okay.
What about the division?
Now we will divide by
3.4.
3.4. It will give me 16.66.
Yeah.
Rather than 6.29, it will give me 16.66. So I will write 16.7 meter per second, or you can also write 17 meter per second. Okay, so what we found from this problem gave us two things. First, if something going up and down all together, then what we need to do? We need to put G negative. Secondly, if the displacement is the same, initial and final position is same, displacement will be 0. But if the same question is asking that what is the height, the second part of the same question is what is the height. So I will consider it as a second part, a different question, and I will do it again in another way. This is the ball that is initially moving to some height. I told you the initial velocity of the ball we just calculate is 16.7 meter per second. Yes. You throw it with this, when it will reach at maximum height, V naught will be 0 meter per second. Now, the acceleration going up is negative 9.8 meter per square second, and we are asked to find y minus y naught. So now in this one, time, if we don't want to use time, then use the third equation of motion. If you want to use the time, which was given 3.4 seconds, then you can use the second equation of motion. So you are having all 5 factors here. Y minus y naught is to find, time is there, acceleration is there, V and V naught is there. So you can use second or third, any of them. So here I'm not going to use the time, I'm just going to use V and V naught. So I will use the third equation. What is that third equation? Third equation is 2g y minus y naught is equal to V squared minus V naught square.
A question before proceed.
Yes.
Should it be V naught and up should be V?
No, first up. Yeah. That's you are right. Sorry, yeah. That is my mistake. Sorry, you are right. This is V and this is V naught. Thank you for your correction. Because when you start the motion, it's initial, and when we stop at the So this one is 2 into negative 9.8 y minus y naught is equal to V squared is 0 minus V naught is 16.7 squared. So when you multiply this, this is negative 19.6 y minus y naught. And what is the square, by the way?
The square is negative 278.89.
Divide by 19.6 negative
19.6.
So the
negative, height positive 14.22.
14.2 meters. So this is the height that is maximum it attained, and it is moving. So I don't think so there is some issue in this one. This was the our question that we know this is 2.7 all about, and it's not that hard that we can feel that it will be. So what we need to take care that when our object is going upward, G is negative, downward positive, upward and downward negative. If displacement is starting initial point is same, then it is 0, and rest just make the table and use to draw and so on.